This video is about the volume of solid of revolution generated by revolving the plane region about the horizontal axis and about vertical axis by shell method. The shell method involves the slicing through the solid using circular cylinders of increasing radii so that the axis of each cylinder is parallel to the axis of revolution, like cookie cutters. Use the shell method whenever washer method requires to express the x values in terms of y, and there is no easy way to do it. Shell method. When the axis of revolution is vertical, so you place the rectangle in the region parallel to the vertical axis. So you say parallel to vertical. This is vertical axis, say rectangle is parallel. So then the formula would become 2 pi times a to b p of x h of x dx. What is p of x? P of x is the distance of the rectangle from the axis of revolution, and this should be x because it varies. It depends on where you place the rectangle. So p of x is always x when you place the rectangle parallel to the axis of revolution. And h of x is height of the rectangle, and it depends, and this is equal to y, depends on the equation of the boundary, upper boundary. Now the shell method, when axis of revolution is horizontal, so we're placing the rectangle parallel to the horizontal axis, and this formula becomes v is equal to 2 pi from c to d p of y h of dy. So this dy. So p of y would be the distance of this rectangle from this one, since the variable. So p of y would be, in this case, will be always y. H of I depends on the, because that's the distance between this boundary and this boundary. So it depends on this difference between two boundaries. So there will be difference of y values. So here is an example. Use the shell method to write and evaluate a definite integral that represents the volume of solid generated by revolving the plane region about the y-axis. So here's a plane region. It's a triangular plane region whose this boundary, the equation is y equal to 1 minus x. So the rectangle is placed parallel to the y-axis, which is the axis of revolution. So the p of x would be the distance of a rectangle from this y-axis, and it's variable. So the p of x would be x, and h of x would be the height, and h of x would be equals to the height from here is 0 and it's y, which is 1 minus x. So we have a p of x is x and h of x is equal to y equal to 1 minus x. And the x ranges from 0 here and here 1. So the formula we're going to use 2 pi a to b p of x h of x d of x. So we can use a 0 and b is what? 1. And p of x is in this case x, and h of x is y, which is 1 minus x. So now we have an integral 2 pi from 0 to 1 x times 1 minus dx. So we distribute x, we'll get x minus x squared and dx. We can use power rule. So then we have 2 pi and x becomes x squared over 2 minus, and then x squared becomes x cubed over 3, and then we're going to take the limits from 0 to 1. So first you substitute 1, so it becomes 1 squared over 2 minus 1 cubed over 3 minus, and then substitute 0, becomes 0 squared over 2 minus 0 cubed over 3. But this goes to 0, now you're left with what? 2 pi, 1 squared is 1, 1 cubed is 1, so 1 half minus 1 third. So to add these two fractions, find the LCD, and LCD is 6. So you multiply 3 tau on the top, 3 on the bottom, we get 3 6, and here you multiply 2 tau on the top, 2 on the bottom. This becomes 2 6. So this becomes 3 minus 2 is 1, so it will be 2 pi times 1 6, which would be pi over 3. So the volume of solid of revolution is pi over 3. So here is another example. Example 2, use the shell method to write and evaluate definite integral that represents the volume of the solid generated by revolving the plane region about the x-axis. So we place the rectangle in the region, this is the region, parallel to x-axis. So in this case, py, the distance of rectangle from the axis of revolution be y. And the distance, the length of this rectangle would be the difference between what is the x value on the y-axis 0, and what is the x value on this boundary. So we have to find this x value in the boundaries. We have to solve this equation. X plus y squared equals 16 for x. So this becomes x equal to 16 minus y squared. Okay, so now we have a p of y is equal to y, and h of y is 16 minus y squared. And y ranges from here 0 and here 4, 0 to 4. And the formula we're going to use v is equal to 2 pi integral from c to d p of y h of y dy. So this will become 2y, and c is 0 and d is equal to 4. P of y is y, and h of y is 16 minus y squared. A distribute of y becomes 16y minus y cubed. The integral from 0 to 4, use the power rule, and becomes 2 pi parentheses 16 times y squared over 2 minus y to the 4 over 4. So limit from 0 to 4. So we plug 4 first. It's going to 2 pi parentheses 16 minus 4 squared over 2 minus 4 to the 4 over 4 minus 16 times 0 squared over 2 minus 0 to the 4 over 4. Well, this goes to 0, and it's become 2 pi. 4 squared is 16, divided by 2 is 8, 8 times 61, 28. 4 to the 4 divide by 4, so it become 64. So subtract gives you 64. So 2 pi times 64 is 128 pi, and that's the volume of this solid. So here is an example 3. We're going to use the shell method to find the volume of the solid generated by revolving the region bounded by the graphs of y is equal to 2x minus x squared, y equal to 0, and the line x equal to 4. The first thing we're going to do is we're going to graph these equations. So first we're going to sketch y is equal to 2x minus x squared, y equal to 0, and x equal to 4. And here's the graph. And I did this one creating a table. And here's a table of values. I plotted the point 0, 0, 1, 1, 2, 0. And then I connect this one. And this is the graph of x equal to 4. Okay, and we're going to revolve about this vertical axis, x equal to 4. So since axis of revolution is vertical, we're going to draw a rectangle in the plane region parallel to the axis of revolution, x equal to 4. So now the height would is y, and y is the equation of this boundary, which is 2x minus x squared. So that's the height of the rectangle. And that's the p of x. So p of x is from here to here is 4, and from y-axis to this rectangle is x. So the p of x is 4 minus the x. And let's see, the plane region here is 0 x value, and here is the second x value is b is 2 here. So now the formula we're using, v is equal to 2 pi integral from a to b, p of x, h of x, d of x. So the volume becomes 2 pi integral from 0 to 2, 4 minus x, 2x minus x squared. So now we multiply these two binomial. So 4 times 2x becomes 8x, 4 times negative x squared minus 4x, and then minus x and 2x will be minus 2x square, and then x times x square becomes plus x cubed. Now we combine the like terms, so we have 8x, 4 and 2 becomes 6 minus 6x squared plus x cubed. Now we integrate by power rule. So it becomes 2 pi times 8 times x squared over 2 minus 6 times x cubed over 3 plus x to the 4 over 4. Now we input and take the limits from 0 to 2. So first we substitute 2. So this becomes 2 pi 4x squared plus 2x cubed plus x over 4. And this becomes 4 times 2 to the square minus 2 times 2 to the cube plus 2 to the 4 over 4. And then you put 0, becomes 4 times 0 square minus 2 times 0 cube plus 0 to the 4 over 4. That goes to 0. So we simplify this one. 2 square is 4, 4 times 4 is 16, 2 cubes is 8, 8 times is 16, and 2 to the 4 is 16 divided by 4 is 4. 16 cancel out, so you get 2 pi times 4, which is 8 pi. So that's the volume of solid of revolution. Example 4. We're going to shell method, and we're going to write and evaluate the of an integral that represents the volume of solid generated by revolving the plane region about the x-axis. This is x-axis. So it's a y is equal, the region, planar region is bounded by this equation y equal to square root of x plus 2, y is equal to x, and y equal to 0. So we're going to graph all this one to create a plane region. So let's first figure out y is equal to square root of x plus 2. Well, it looks like the domain of the square root is x is bigger than minus 2. So you're going to start with negative 2. So substitute gives you 0. And then it's substitute next higher value, negative 1. And that will give you 0 also. And then next is 2. So this becomes 2 plus square root of 2 is equal to square root of 4 equal to 2, so we 2, 2. So these are the points we plot, and we get this equation. Okay, so now we graph y is equal to x on the same xy plane. So create a table. I chose x equal to 0, and y becomes 0. So you have a 0, 0 point. And I chose x equal to 2, and then become y is equal to 2. Second point, so you plot 0, 0 here and 2 here. Connected these 2 points, you become a line. So now this is the plane region bounded by this and this line and x-axis, which is y0. You're going to revolve about the x-axis. So since we're revolving about the x-axis, so we're going to draw a rectangle parallel to the x-axis. So here we have a rectangle which is parallel to the axis of revolution. Okay? Now we have to find the length or height of rectangle and the distance of rectangle from the axis of revolution. So we have equation y is equal to x. We're going to solve for x equal to y. We have equation y equal to square root of x plus 2. We have to solve for x. So you square both sides, become y squared equal to square root of x plus 2, which becomes x plus 2. Move the 2 to the left, it becomes y squared minus 2 is equal to x. Or you can say x equals to 1. Y squared minus 2. So the height of rectangle is the x value on this line, and the x value is on this line. So we have to subtract this value from 0 from this x value. So it becomes y minus, so here's the value of y, here x is equal to y squared minus 2. So we simplifying h of y is y minus y squared plus 2. And the distance of rectangle from the x revolution is just y. Shell method requires to use the formula v is equal to 2 pi integral from c to d p of y h of y dy. So substitute c equal to 0. C is the lower limit, lower value of y. So this is the lower. Here y is 0, so c is 0. And here that's the highest point on the region. And here y value is 2, so we're going to use d is equal to 2. And p of y is the distance y, and h of y is that's the height of the rectangle. So this integral becomes v is equal to 2 pi integral from 0 to 2 y times y minus y squared plus 2 dy. Distribute y becomes y times y squared y cubed 12. Now use the power rule of integration because y squared becomes y cubed over 3, y to the 3 becomes y4 over 4, and 2y becomes y squared over 2. 2 cancel gives you y squared. Now we substitute the upper limit 2 first, so you can 2 pi 2 cubed over 3 minus 2 to the 4 over 4 plus 2 squared minus substitute lower limit 0 cubed over 3, 0 to the 4 over 4 minus 0. Well, this goes to 0. Forget about this. Now simplify this. 2 cubed is 8, so it becomes 8 third. 2 to the 4 is 16, divided by 4 is 4. 2 to the square is 4. Now 4 cancels with 4. You're left with 2 pi times 8 over 3, which is 16 pi over 3. And that's the volume.